Okay, guys, let's speak about circuits, guys. Circuits. I'm not gonna discriminate. Grade 11, grade 10, grade 12. It's the same thing. You need to know this stuff. Okay, circuits, guys. Let's start by connection. It's the stuff you know, guys. Connection in the circuits, the series part of the circuit. That is the series part that is series. Okay, in the circuit. So we're talking about resistors that are connected in series in the circuit. Okay, guys. What happens there? So the voltage, guys, voltage is shared there. Okay, all right. And then on the current, it remains the same. Let me also put that current remain the same there. Okay, this is the stuff you know. And parallel part, but actually current is shared and voltage same. Okay, doesn't change. It's the same voltage. It's equal in that part. Okay, that is very important, guys. Another thing that I quickly want to pass through before I can explain to you what is the meaning of that is this one. So the connection of ammeter. Why is the ammeter always connected in series? Why is the voltage always connected in parallel? Because, guys, that is usually 1 mark sometimes in your paper. Because, guys, ammeter has got insignificant, significant resistance. Okay, what does that mean? It means it will not go against the current. It will not stop the current. It will not affect the current, even if there's a current flowing in there. Okay, and then another thing, sometimes they say even conductor. If you press and put the wire, what the wire, which is the corner, has the voltage. I mean, it has the resistance, but it is insignificant. All right, what about the voltage? Voltage is always connected in parallel. You can see, guys, it's always parallel. You don't see it in series because it has high resistance. Okay, which means if you can connect it where there will be a flow of current, the current will not flow because of its high resistance. Remember, the resistance goes against the current. Okay, it actually affects the current. Now let's look at this now. So this is the circuit you've got, guys. Let's start by the current. What is happening in the current here? The current, guys, comes in. If it comes in this side, you need to know the direction of the current again, guys, from the battery. The current that is produced in the battery flows is still the same because it can't come here, because this is the voltage and it has highest resistance. It flows in here, flows in here, flows in here, flows in here. Here it cannot split because this is the voltage, but when it gets here, it's actually split. How does it split? According to the ratio of the resistance that is gonna flow. So where there's less resistance, more. There will be more resistance, there will be less current. And then it goes back again, you get the total current again, and then it flows. You get the same current that was produced when you are here. Current is not lost, it just split in the second. It's the same current that is produced in the battery. That is very important. Now let's look at the voltage, because I spoke about the voltage being shared. So, guys, now only on this part, remember, first thing, voltage V total that is produced by the battery is always voltage in series plus the voltage in parallel, guys. But now the voltage in parallel is equal everywhere. In this case, V1 will be equal to V2. Yeah, that is V2. You understand, guys? It doesn't matter if they give you this one, it is the same as this one, but it is not equal to VT because you still have the voltage that is still connected in series. Because this resistance, it is actually connected in series to both of these resistors. That's why we cannot say, if there was nothing here, we're going to say then VT also is equal to those voltages. But this one, let's say now I add another resistor there. Okay, and then obviously it will have its own voltage there. So you see now, we're gonna say now, for us to get the voltage total now, voltage total from that will be equal to voltage in series. Remember, in series we add them. This one plus this one, they are in series. This voltage and this one, they are in series, but they are also in series to this one. You understand, guys? So we're gonna have V, I'm gonna call this one V4. So V1, right, Vp, which is this one, is equal plus V3 plus V4 is our voltage total, guys. It is very important you understand that in this circuit, you, as much as this is a parallel, it is also in series to this one. This whole part is in series to that one and this one. Okay, that's why we are adding them. Usually the voltage is just, the voltage here is equal to this one because it's a series. Okay, maybe let me speak about the series. Voltage in series connection. Voltage in series is going to be equal to V1 plus V2 plus V3 and so forth. All right, that's why we are saying here voltage parallel, because parallel plus this one plus that one, because parallel, as much as it's parallel, it is also in series to that one. That's why that applies now. Okay, that is very important for you guys to understand. Now guys, I'm gonna speak about, in the next video, I'm gonna speak about internal resistance on this circuit if we introduce it.